Let's begin a review of fluids. First of all, density. You learned this probably in grade 6. Density is mass over volume in grams per cubic centimeter or kilograms per cubic meter. The only difference is the symbol for density is the Greek letter rho, and you need to get used to that. You will see that constantly as representing density. You need to know the density of water, 1 gram per cubic centimeter, or 1,000 kilograms per cubic meter. Good numbers to know. There's something called specific gravity. It's a fancy name, and all it means is, oh, this compared to water. You divide the density of something by the density of water, the units cancel out, and you get a simple number. So if you have a specific gravity, say of 1.5, that means it's 1.5 more dense than water, and it will sink. If it's less than 1, it floats. Buoyancy. Now you'll need to work this one through very carefully. The weight of the volume of liquid displaced is equal to the buoyant force up. If I push a brick under water, it pushes aside water. The weight of that water is how much force, the buoyant force, is pushing up. But I notice your book has a very simple little formula to calculate this. So here is a block that is partially submerged. Take a look, right where the arrow is. It's partially submerged. And I'm going to derive a formula that will show you the buoyant force. Now, the volume of the submerged part equals the volume of liquid displaced. Very straightforward. Hit pause at every point to understand. The density of the liquid, maybe water or not, is the mass of the liquid displaced divided by the volume of that liquid displaced. Let me rearrange this so that I have the volume of liquid, and I'm going to replace that for ml over rho L. So the volume of the submerged part is equal to the mass of liquid that was displaced divided by the density of liquid. So I multiply by density on that side, multiply by G on both sides. Now, look at the formula that I have. The density of the liquid times the volume of the submerged portion times G equals, that right there is the buoyant force. So I can just replace it with the buoyant force. Now, you don't have to remember this derivation, but it's probably good to memorize this formula. Pressure, of course, is force over area. And the units are newtons per meter squared, which is also called a Pascal, capital P-A. You need to know that for sure. The illustration I gave last year, I think, is quite good. Somebody's 150 pounds in flat shoes. Well, their pressure is the 150 divided by the area. They are exerting, look at this, when I divide it out, only 6 pounds per every square inch. That's all, not very much because it's spread out over the flat shoes. But if they wore stiletto heels that were maybe even a 1/16 of an inch square, you have the same pressures, force over the area, and look what happens now. The pressure, because of that small area, 2,400 pounds spread over that square inch. Absolutely amazing. Understand that concept. Now, the other thing that you should be familiar with would be the atmospheric pressure. And this is what it is, and you would be given that.